For all of human history, every person who has ever looked up at the night sky has seen the exact same face. From the ancient Egyptians to modern astronauts, we have all stared at the same craters and the same seas. It is as if the moon is refusing to turn around. There is a popular myth that the moon doesn't spin, but that isn't true. If the moon didn't spin, we would actually see its entire surface as it orbited us. The truth is much stranger. The moon is hiding its back from us on purpose, locked in a gravitational grip so tight that it forces it to stare at Earth forever. We call it the man in the moon, that familiar arrangement of dark patches and white highlands that looks like a face. No matter where you are on Earth or what time of year it is, you only ever see that face. The other side, often incorrectly called the dark side, remains permanently turned away from us. This isn't a coincidence, and it isn't bad luck. It is a phenomenon called synchronous rotation. It is the result of a billions of year-long tug-of-war between the Earth and its satellite. Welcome to Space Facts. Let's spin the moon. To understand this, we have to kill the myth that the moon is stationary. The moon does rotate on its axis, but here's the trick. It rotates at the exact same speed that it orbits the Earth. It takes the moon about 27 days to make one full circle around the Earth. It also takes the moon exactly 27 days to spin once on its own axis. Imagine you are walking around a bonfire. If you want to keep your face toward the fire the entire time, you have to slowly turn your body as you walk. By the time you have made a full circle around the fire, you have also made a full 360-degree turn with your body. That is what the moon is doing. It is pirouetting with perfect precision so that one side always faces the center. If the moon didn't spin at all, as it moved to the other side of Earth, its face would still be pointing in the same direction, meaning it would be pointing away from us. The fact that we see the same face proves it is turning. But why? Why would it match up so perfectly? The answer is gravity acting as a physical brake. When the moon was formed billions of years ago, it spun much faster and was much closer to Earth. But the Earth's gravity is powerful, and it doesn't pull evenly. Because gravity gets weaker with distance, the Earth pulls harder on the side of the moon facing us than on the side facing away. This differential pull, called the tidal force, actually stretched the moon physically. The moon isn't a perfect sphere. It is slightly egg-shaped or football-shaped, with the nose of the football pointing at Earth. As the young moon tried to spin fast, that nose kept getting dragged back by Earth's gravity. This created torque, a twisting force that fought against the spin. For millions of years, Earth acted like a giant friction brake, slowly draining the moon's energy and slowing down its rotation until the nose was permanently locked, pointing at us. The moment the rotation speed matched the orbital speed, the torque stopped and the lock was complete. This is called tidal locking. However, the lock isn't absolutely perfect. We actually see a little bit more than 50% of the moon. We see about 59% over the course of a month. This is because of a phenomenon called libration, which is essentially a lunar wobble. The moon's orbit around Earth isn't a perfect circle, it's an ellipse, an oval shape. Kepler's laws of planetary motion tell us that when an object is closer to the thing it orbits, it moves faster. So when the moon is at its closest point, perigee, it zooms ahead in its orbit. But its rotation speed, the spin, stays constant and steady. This mismatch causes the moon to lag behind its own orbit, allowing us to peek around the eastern edge. Conversely, when it is far away, apogee, it moves slowly and the rotation gets ahead, allowing us to see around the western edge. It literally nods up and down and shakes its head left and right, revealing slivers of the far side that would otherwise be hidden. For millions of years, the far side was a total mystery. Humans imagined it might have aliens, secret bases, or vast oceans. It wasn't until 1959 that the Soviet probe Lunar 3 swung around the back and took the first grainy photos. What we found was shocking. The far side looks completely different. The side facing us is covered in maria, those dark, smooth seas of ancient solidified lava that make up the man in the moon. The far side has almost none. It is a rugged, battered wasteland covered almost entirely with craters and highlands. Why the difference? Scientists believe that Earth's gravity kept the near side's crust thin and hot due to tidal heating. When asteroids hit the near side, lava easily oozed out to fill the scars. But the far side cooled down faster and developed a much thicker crust, almost like a shield. So when asteroids hit the back, they just left dents instead of lava lakes. The face we see is the scarred face. The face we hide is the shielded one. The reason we only see one side of the moon isn't because it is still, it is because it has surrendered to Earth's gravity. It is a celestial dance partner that refuses to break eye contact. While we have now mapped the far side with satellites, looking up from your backyard remains a one-sided experience, a constant reminder of the invisible tether that binds our two worlds together. If this new perspective on the moon illuminated your mind, hit that like button. Subscribe to Space Facts for more orbital mechanics explained simply.